Hello everyone, so today I'm going to go over lesson 8.2. We're still continuing in our unit on right triangles, and remember in the last lesson I talked about how right triangles have some special rules that we can apply to them that don't apply to other types of triangles. So in this lesson we're going to talk about special right triangles, and there's two different types. The first one is a 45, 45, 90 special right triangle. And what that means is that it's a right triangle where there's a 90-degree angle, and then the other angles both measure 45 degrees. And if you remember that all the three of the angles of a triangle always add up to 180, if you take 90 plus 45, we'll get 180. So this is a special right triangle because we might see these a lot throughout the rest of the unit. So remember that the sides like here are called legs, and we're going to learn about a special pattern that applies to 45, 45, 90 triangles. The leg, we can label that as like X because they're going to be the same length. Notice how they look like they're about the same length, and we know that is true considering that we've talked about how if their angles are the same, that means that these sides are the same. Those are isosceles triangles. So the hypotenuse then is also always going to follow a pattern. What we're going to refer to it as is x root 2. And what that means is that whatever number your x is, so say it's like it measures 2, then your hypotenuse is going to be 2 root 2. Something like that. So let's go ahead and practice this. Like in number 1, it just says to find the value of each missing variable, we need to find x and y. So something to keep in mind is that the legs of a 45, 45, 90 triangle are always congruent. So here we can see that one of the legs is 8, so the other leg also has to be 8. So let's go ahead and call that 8. Then the y is just whatever your x was and root 2. So it would be 8 root 2. So I'll often refer to the pattern for 45, 45, 90 triangles as 1, 1, root 2, just because you can think of as the x as being like ones, and then the root 2 as being whatever your leg is and the root 2. And what's really happening here is multiplication. This is like 8 times root 2. We just don't need to put a multiplication symbol. When they're right next to each other, it's automatically multiplying. So let's look at number 2. This is also a 45, 45, 90 triangle. This is a leg, and so it's going to be the same as this other leg. So it's also going to be 25. So we can write 25 there. And then that's supposed to go in the y, actually. And then our x, that's the hypotenuse, and the hypotenuse is just whatever your x is and root 2. So since our x was 25, or our leg, in this case that's labeled as y, we would call our hypotenuse 25 root 2. So number 3 is a little bit different because now we need to find both of the legs. This time they're only giving us the hypotenuse. So how do we work backwards to find out what the legs are? We know that they're going to be the same, so whatever we get for one is the same thing that the other one's going to be. But if you think about it, whatever this number is, we just multiply it times root 2 to get this number. That's what we did here. We took 25. 25 times root 2 is just 25 root 2. And that's what our hypotenuse would be. So if we want to work backwards, we have to take this number and divide it by root 2. So 19 divided by root 2. When we're seeing fractions like this, something that we need to do is make sure that there's no irrational numbers in the denominator. And what I mean by that is root 2, when you put that in your calculator, it's going to be one of those decimals that keeps going on forever and ever, and there's no pattern to it. So that's what we call an irrational number. The denominator is just like the bottom part of the fraction. In math, we are just not allowed to put irrational numbers in the denominator of a fraction. We have to rationalize it. And so what we can do to change how this number looks, but still keep it the same value, is multiply it by 1, but just a special form of 1. And a special form of 1 that would help us in this case is by multiplying by root 2 over root 2. Root 2 over root 2, if you do the math on that, it's just 1. It's root 2 divided by root 2. But by doing this, 19 times root 2 is simply 19 root 2. And then root 2 times root 2, I'm going this way and this way, that simplifies to 2. So now this can be our answer. 19 root 2 over 2 is our x, and then our y is the same thing, 19 root 2 over 2. So that's 45, 45, 90 triangles. Let's talk about 30, 60, 90 triangles. So that in these, the legs are not the same. There's a shorter leg and a longer leg. The shorter leg is across from the 30-degree angle, and then the longer leg is across from the 60-degree angle. The hypotenuse then, just like any right triangle, is across from the right angle. So this one has a slightly different pattern. I'm no longer going to talk about as 1, 1, root 2. Instead, I'm going to call it 1, 2, root 3. So the shorter leg, that's going to be like the 1, or you can think of it as x. And then the hypotenuse is going to be like the 2, or 2x. So what that means is you take whatever your x is, whether it's like 2 or 3, and multiply it times 2, or double it. So that means your hypotenuse is always going to be double what your shorter leg is. And then the longer leg is where the root 3 comes in. So that's whatever your shorter leg is times root 3. And something that we'll talk about is that it's okay to just leave the square roots in your answers. You don't have to like put that in your calculator and find out what the decimal answer is. It's okay to leave it like that, as long as it's like in simplest form, which we'll see a little bit about how to simplify square roots. So let's try to practice with some 30, 60, 90 triangles. A number 4, I can tell that it's 30, 60, 90 because there's a right angle, a 60-degree angle, so that means this has to be a 30-degree angle. So the first thing that I always do when I see these is mark it up using what I know about 1, 2, root 3. So the 1 side is always across from the smallest angle, the 30-degree angle. So this is like my 1 or my x. My 2 is the hypotenuse. So this hypotenuse has to be double what my smaller leg is. My smaller leg is 5. So if I multiply 5 times 2, I would get 10. So the hypotenuse is 10. And then because my longer leg is just x root 3, I just take whatever my x is and then put a root 3 at the end of it. So since my x or my shorter leg is 5, this is going to be 5 root 3. Okay, and that's it. So number 5 is also a 30, 60, 90 triangle. I'm given the smallest leg. That's across from the 30-degree angle. And I know that the hypotenuse is whatever is double the smallest leg. So what's double 14? That would be 28. So 28 is my hypotenuse. And to find my longer leg, I just have to take that 14 and put a root 3 after it. So 14 root 3. And that's totally fine to leave as my answer. I don't need to find out what that is as a decimal. Okay, number 6 is also a 30, 60, 90 triangle, but this time, instead of giving us one of the legs, they're giving us the hypotenuse. So how can we work backwards to find out what the legs are? Well, if I know that the hypotenuse is just double the shorter leg, if I can take this 32 and divide that by 2, that's going to be what my shorter leg is. 32 divided by 2 is 16, so that's 16. And then my longer leg is just whatever my shorter leg is, and then with the root 3 at the end. So y is going to be 16 root 3. Number 7, again, we're given the hypotenuse. So I can just take that number 46 and divide it by 2, and that'll give me my shorter leg. 46 divided by 2 is 23. The shorter leg is going to be the y in this instance. So I'm going to write 23 over here. And then my longer leg is just 23 root 3. And that's my answer. All right, number 8 is going to be a little bit different because this time they're giving us the longer leg. It's across from the 60-degree angle. So how can I work backwards to find the shorter leg, which is also going to help me find the hypotenuse? Well, if I know that the longer leg is just whatever the shorter leg is multiplied times root 3, I just have to do the opposite. I just need to divide 20 by root 3. If I'm dividing by a square root, I have to rationalize it. So I need to multiply by a special form of 1, which in this case, I'm going to use root 3 over root 3 so that I can get rid of the square root on the bottom. So I'll end up with 20 root 3 over, and then root 3 times root 3 just simplifies to 3. So that is what my shorter leg is, my y. So I'm going to write 20 root 3 over 3. So how do I know what the hypotenuse is? Well, I pretty much just need to take 20 root 3 times 2. And really, you can leave the root 3 over 2 part and just multiply the 20 part times 2. Well, 20 times 2 is 40. So the hypotenuse is 40 root 3 over 2. Hopefully that makes sense. All right, and number 9. So I'm starting with the longer leg again. It's across from the 60-degree angle. So I need to do the same thing that we just did. I need to take 9 root 3 and divide that by root 3. Well, the good thing about this one is that I don't really need to do much, considering that whenever you divide something by itself, it just comes out as 1, right? And so if I see that root 3 is on the top and root 3 is also on the bottom, that's going to kind of cancel out and just become 1. And 9 times 1 is just 9, so this whole thing simplifies to 9. So that's my shorter leg. My hypotenuse then is just whatever is double the shorter leg. So 9 times 2 is 18. And that's it. So let's go on to the next page and start to do some mixed practice where some of these are 45, 45, 90, and some of them are 30, 60, 90. So number 10, I can tell that it's a 45, 45, 90. Remember that the pattern for these, when it's 45, 45, 90, is 1, 1, root 2. If it's a 30, 60, 90, the pattern is 1, 2, root 3. So our root 2 in the 45, 45, 90 is the hypotenuse. So if I want to know what the legs are, I just need to take whatever my hypotenuse is and divide that by root 2, because I'm working backwards. Usually we take this times root 2, and that's what gives us this. But now I'm working backwards, so I need to divide, do the opposite. I'm going to have to multiply by my special form of 1. I'm going to multiply everything by root 2 over root 2. So I'm left with 28 root 2 on the top, and then just 2 on the bottom. And I can simplify this a little bit more because this 28 divided by 2 is just 14. So really this is all 14 root 2. And remember that in 45, 45, 90 triangles, the legs are congruent. So if one of them is 14 root 2, the other one's also going to be 14 root 2. So let's look at number 11. This is a 30, 60, 90 triangle, and we're given the hypotenuse. So if I want to know what the shorter leg is, I just need to take the hypotenuse and divide that by 2. That's 8. So my shorter leg, y, is 8. And my longer leg is just that shorter leg, root 3, 8 root 3. Number 12 is a 45, 45, 90. So I know one of the legs, which means that I automatically know the other legs because it's just going to be the same number, 4. And then the hypotenuse is going to be that number with root 2 at the end. So 4 root 2. All right, let's look at 13. This one is a 30, 60, 90, and we're given the shorter leg. So this should be pretty easy because I can find the hypotenuse just by doubling that number. So my y is going to be 22. And then I can find the longer leg just by putting a root 3 after the shorter leg. So 11 root 3. Okay, let's look at 14. Well, we are given the longer leg. So if I want to find the shorter leg, all I really need to do is think, okay, this number, we just attach a root 3 at the end, and that's how we get our longer leg. So if I just take off that root 3, that's what my shorter leg would be. So my shorter leg is really just 15. You could think about it as, well, it's 15 root 3 divided by root 3. This cancels out, so I'm left with 15. Or you could just think about it like taking off that root 3 from the end. And if this is 15, the hypotenuse is going to be whatever's double 15, because the pattern is 1, 2, root 3. So what's double of 15? That's 30. All right, so let's look at the next one. This is a 45, 45, 90, and we're told that the hypotenuse is 9 root 2. So if I want to know what each leg is, think about it. The pattern is 1, 1, root 2. So it's really just 9 and 9, because if the legs were 9, then the hypotenuse would be 9 root 2. So these are both 9. Okay, let's look at 16. I can tell that this is a 30, 60, 90 triangle, and I was given the longer leg. So when I have the longer leg, I need to divide by root 3 in order to find what the shorter leg is. So I'm going to do that, but then I have to multiply by my special form of 1. So I'm left with 6 root 3 over 3. 6 divided by 3 is just 2, so this simplifies into 2 root 3. So that's my shorter leg, which is labeled as y. So I'm going to write that here. And my hypotenuse is whatever's double this. So really you just need to take 2 root 3 times 2, which all we multiply here are the 2. So 2 times 2, that's 4, and then just bring over the root 3. So it would be 4 root 3. So with number 17, I know that I have the hypotenuse, and I need to work backwards to find out what the legs are. So since the hypotenuse in a 45, 45, 90 triangle is just the length of the leg times root 2, to work backwards, I just have to divide the hypotenuse by root 2. So root 10 divided by root 2. Whenever you see that the top and the bottom both have square roots, you can just divide those numbers, kind of like 10 divided by 2. You just need to carry that root with you. So 10 divided by 2 is 5. So what this simplifies to is root 5. That's something that you hopefully learned in Algebra 1 or Algebra 2. If you don't remember, that's something that you are allowed to do. So in a 45, 45, 90 triangle, the legs are the same, so both of these are root 5. Okay, let's look at 18. I know the hypotenuse is 38, so I can divide that number by 2 to find the shorter leg. That's 19. So my shorter leg, or x, is 19, and then my longer leg is just 19 root 3, because that's the pattern here. So number 19 is going to get more complicated because now we're dealing with multiple triangles. We have a 45, 45, 90 triangle, and we also have a 30, 60, 90 triangle. So I know that this side is 9, and that is the shorter leg of this 30, 60, 90 triangle. So I can find z because that's the hypotenuse. So I just need to take 9 times 2. Well, 9 times 2 is 18, so z is 18. I can also find the longer leg because the longer leg is just whatever my shorter leg is with a root 3 at the end. So 9 root 3. Knowing that is going to help me figure out what x and y are, the legs of the 45, 45, 90 triangle. Because if the hypotenuse of this 45, 45, 90 triangle is 9 root 3, I just need to take that and divide it by root 2. So what I need to do is multiply by root 2 over root 2. That way I can get rid of the root 2 on the bottom. 9, and then root 3 times root 2 is going to simplify to root 6. 3 times 2 is 6. And then I'll have a 2 at the bottom. Root 2 times root 2 is just 2. So that's what my legs are of the 45, 45, 90 triangle. 9 root 6 over 2, and then 9 root 6 over 2. All right, number 20 is the same kind of situation where we have a 45, 45, 90, and then a 30, 60, 90 that are connected or touching. So I want to look at what I have. I'm given this leg of my 45, 45, 90 triangle. So I can find the hypotenuse, or x, just by taking that times root 2, because for a 45, 45, 90 triangle, the pattern is 1, 1, root 2. This is like my 1. So the hypotenuse is going to be 32 root 2. What else can I find? Well, if I know that this is 32, then I know that this is 32 as well. And that helps me because that's the hypotenuse of the 30, 60, 90 triangle. So now I can kind of work backwards to find the shorter leg and the longer leg of that triangle. So remember that the shorter leg is just the hypotenuse cut in half or divided by 2. So 32 divided by 2 is 16. So that's what my shorter leg is. And then the longer leg is just whatever your shorter leg is and then add a root 3 at the end. So 16 root 3. All right, almost done. So 21 has a hypotenuse of a 30, 60, 90 triangle. So I can work backwards to find out what the shorter leg and the longer legs are. So if I want to find my shorter leg, remember that it's basically just half of the hypotenuse. So the shorter leg is going to be 6. And that means that the longer leg would be 6 root 3. That helps me because now when I look at the 45, 45, 90 triangle at the bottom, I know one of the legs, and remember that the legs are congruent. So y is also going to be 6 root 3. And if I want to know the hypotenuse, I just need to take that times 2. So what is 6 root 3 times root 2? That's going to be 6 root 6. We multiply the 3 and the 2 inside of the square roots. So 6 root 6. And then 22. So what I'm seeing is the 30, 60, 90 triangle and another 30, 60, 90 triangle. There's one, and then here's one. And then I also just have a 30, 60, 90 triangle, like in the big version. So what's going to help me is first, if I use the 7 root 3 to find my longer leg, because that's the shorter leg. So if I want to find the longer leg, remember that in a 30, 60, 90 triangle, the pattern is 1, 2, root 3. And the shorter leg is like the 1, the hypotenuse is like the 2, and the longer leg is like the root 3. So I basically just need to take 7 root 3 times root 3 to get my longer leg. So I'm just going to multiply the numbers that are both under square roots. So I'm going to be left with 7 root 9. And if you think about, well, root 9 is a perfect square. Root 9 is 3. So I basically have here 7 times 3, and 7 times 3 is 21. So right here I have 21. So I know that's 21, and that's going to help me in a little bit. I can use this 7 root 3 also to find out what x is, because that's the hypotenuse. So if I want to know the hypotenuse, usually I would take my 1 and then multiply that times 2. So 7 root 3 is my 1, and I'm going to multiply this times 2. 7 times 2 is 14, and then I'll just bring over the 3. So this is 14 root 3. This 21 is going to be helpful to find the z and the y. So if you think about 21, that's the shorter leg of this one. So the shorter leg, if we double that, that gives us our hypotenuse. So 21 times 2, that's 42. So that's my hypotenuse, which in this case is y. So this is 42. And then to find my longer leg, I just take 21 and then put a root 3 at the end. So 21 root 3. All right. And then let's look at 23. So I have a 30, 60, 90 triangle and a 45, 45, 90 triangle. I know the hypotenuse of that 45, 45, 90 triangle. It's 15 root 2. Well, I can easily find what the legs are, because 15 root 2, if I divide that by root 2, I'm just going to cancel out the root 2. So this is 15 and this is 15. So I know that z is 15. Now, focusing on the triangle on the left, I know that the longer leg is 15. So how can I work backwards to find the shorter leg and the hypotenuse? Well, in the pattern for 30, 60, 90, it's 1, 2, root 3, and root 3 is the longer leg. So if I want to know what my shorter leg is, all I have to do is divide this by root 3. So I'm going to multiply this by root 3 over root 3. I'm going to be left with 15 root 3 over 9. Oops, not 9. It should be 3. And 15 divided by 3 is just 5, so we have 5 root 3. And that's what my y is going to be. That's my shorter leg. And if I double that, that gives me my hypotenuse. So 5 root 3 times 2 would just be 10 root 3. And then lastly, number 24. So I know that the 60-degree angle would be here. So this 18 is my longer leg. And I can use that to work backwards, just like how we did before, and find the shorter leg by dividing by root 3. So 18 divided by root 3, I'm going to multiply by a special form of 1. That gives me 18 root 3 over 3. Well, 18 divided by 3 is 6, so I have 6 root 3. That is my shorter leg, which is the z. So 6 root 3. I could find the hypotenuse of that triangle, which also happens to be the hypotenuse of the other triangle, by just doubling 6 root 3. That's going to be 12 root 3. And then I can work backwards with that 12 root 3 and divide that by root 2 in order to get the legs. So I'm going to divide by root 2 over root 2. Multiply times root 2 over root 2. That's going to give me 12 root 6 over 2. And that simplifies to simply 12 divided by 2 is 6, and then root 6. So this is 6 root 6, and y is also 6 root 6. So that's the lesson on special right triangles. Go ahead and make sure that you submit the notes and the homework.